We're going to talk about in behavior today. I want to give you guys a little heads up that on Friday and Monday, I will not be in class. If you are in class, you will be with tolls. But right now, it's nothing like Friday is just a work day anyway, but you need to make sure you get that work done. And then Monday, I will record your notes for you. So y'all need to bring headphones. Okay, that'll work in your but it's long and synthetic division, which is really easy. Okay. And then if you have trouble, absolutely talk to me, email me, let me know, and I'll help you out. And then the next day is actually a review day. So I will go over long and synthetic again. Okay. So don't stress out that you're going to miss anything. You're not going to. Um, I have to help register the eighth graders. So that's where I'm going to be. I'm not going to not be here, but I'll be here the rest of the day. And if you guys have questions during the day and you can come back third period or something like that, I'll be in here. So it'll take literally like 5 seconds. Like it's not a hard concept at all. So I'll try to do a bunch for you, and I'll probably record that on Wednesday, and do a bunch of work for you so that way you guys can see it. So it won't be too bad. Today is in behavior, and it's actually fairly easy. Your homework assignment will be on EDIA today. Okay, so it'll be pretty simple. All right. So we're going to start with the degree of a polynomial. And I'm going to mark out this in the form of, we don't care about that, is the highest exponent. Turn my paper, I can't write straight up and down. All right, so if we look at these polynomials and these bullets here, we're looking for the highest power or the highest exponent. So the highest exponent in this first one is 5, so the degree is 5. That's literally all you do, okay? In the next one, look through it. The highest degree is a 3. So 3 is your highest exponent. And then anytime, I'm going to give you another one down here as well. So just give me a minute. Anytime you just have like 2x plus 1, remember your power is a 1. So it's x to the first. So your degree is 1. So what's the highest number of variables that you have? The highest number is 1x. And then in this one, what's the highest number of variables when you don't have any at all? Your degree is 0. Okay, just to give you an extra little heads up there. So then it's going to ask you about the leading coefficient. So the leading coefficient of the polynomial is the coefficient of the highest degree. And coefficient is just the number with the variable. Okay, the number with the variable. Okay. So we said that our degree was 5. The number with that x is your leading coefficient. So this leading coefficient is 3. So the degree is the highest power. Your leading coefficient is the number in front of x with that highest power. So if we look at the second one, it's the same thing. Our highest power was a 3. The number in front of that x is negative 5. Same thing on the next one. We have 2x plus 1. We said x was our highest, or that 1 was our highest. So the number in front is your leading coefficient. All fairly easy. So then the important one is in behavior. The end behavior of the graph of a polynomial f of x describes the values of f of x at the far right and the far left ends of the graph. So all we're doing is looking at the ends of the graph. There's going to be 4 different ones. Okay, there's going to be 4 different ones. Your first possibility is if when we start on the left, it's pointing down. These little dots mean anything can happen in the middle. It doesn't matter what it is. Okay, doesn't matter. The middle does not matter at all. But if we look at the other end, it's pointing up. I'm going to show you all 4 of them, and I'm going to talk about how to write in behavior, so it's not breaking it up. Okay, so you guys can see it. The next one is if we start pointing down on the left, and then on the right, we're also pointing down. Does not matter what happens in the middle. The next one is we could be pointing up on the left and pointing down on the right. Again, does not matter what happens in the middle. Or it could be pointing up on the left and pointing up on the right. Stay on this page, and I'm going to show you how to write this. One part of your end behavior will never change, and that's how we write the left and the right. So this is what it's going to look like. I'm going to actually put it up here. The way we represent the left side, we're talking about left or right, so we're using X because it goes left or right on your axis. We do an arrow. It says goes to, so that's how you pronounce it. X goes to. And on the left, we go all the way to negative infinity. Okay. You will always use this to represent the left side. Okay, that will never change. To do the right, it's the same exact thing. X goes to, except for on the right, it's positive values, so it's going to go to positive infinity. You will always use this for the right. Those two will never change. The only thing that changes is the f of x part. And the f of x deals with, does it point up or does it point down? Okay. So here's what we do. Okay. So I'm going to split this up. I'm hoping this doesn't bleed through. I'm going to split all these into the left and the right, okay? Just to give you a visual, that's all I'm doing. So this is the left side. This is the right side. Okay. So for the first one, this is how you write it. We're going to start on the left. And remember, I told you x goes to negative infinity, always deals with the left. The next thing you use is f of x. That represents y. Remember, f of x, same thing as y. And on this left side, where does it point? Up or down? Is this pointing up or down? It's not a hard question. Quickly, down. So this is going to negative infinity. That's all you do. All right. So then we're going to talk about the right. Remember how we represent the right side is x goes to positive infinity. Then we write f of x. And where is f of x pointing? Where is it pointing? Up would be positive infinity. That's all you do. Okay. So on every one of these, they're going to start out left and right. And then you're going to tell me which side or which way the left is pointing and which way the right is pointing. So the next one, you're going to do the same thing. We're going to start on the left. So x goes to negative infinity, means the left. And where is it pointing? Guys, come on. Down, so negative infinity. To do the right side, we just do x goes to positive infinity. The right side is also pointing down. So that's also negative infinity. Okay. And again, if you want to expand this, this is only dealing with that one. Okay. I'm going to do the next one in the box so you don't get it confused. Left side is negative infinity. It is pointing up, so positive infinity. To represent the right side, x goes to positive infinity. The graph, or f of x, is pointing down to negative infinity. That's literally it. The next one, the left side is negative infinity. The graph is pointing up. So it goes to positive infinity. The right side, x goes to positive infinity. The graph is pointing up to positive infinity. All right, so on the next one, you're going to do the end behavior. It's going to give you a graph. Remember, the only thing that matters are the two end points. What do the ends do? Okay, so everybody's good with this comment. All right. So here's two graphs, and it says describe the end behavior of the following graph. Remember, we don't care about anything but the ends. And both ends are pointing up. So the left side is x goes to negative infinity. Since the graph is pointing up, it is pointing to positive infinity. The right side of the graph is x goes to positive infinity. This side of the graph is pointing up to positive infinity. Again, it does not matter what happens in between. It could have a million bumps and humps in there, twists and turns, it don't matter. Okay, all that matters is the end. So on the next one, we have the end here and the end here. On the left, x goes to negative infinity. This graph points to negative infinity. On the right side, x goes to positive infinity. I don't know what's going on. What happened? Hang on, guys. I don't know what's going on. Give me a second. Technology on a Monday. See if we can get it back up and running real fast. There we go. All right. And then share. I have no idea what happened. Just decided it didn't want to work anymore. All right, so on the right side, the graph points to positive infinity. Okay, any questions on this? All right, so if they give you the graph, it's really easy to look at, but what if they give you the equation? So there are tricks to these equations, and I'm gonna write them down at the bottom. So we'll come back to this chart, but go down to the bottom, and I'll write this chart for you. Remember that the degree is the highest power. The degree will also tell you whether it's odd or even. So if it's 1, 3, 1, 3, 5, 7, 9, those are odd degrees. If it's even, 2, 4, 6, 8. So just so you remember, 1, 3, 5, 7, anything else. 2, 4, 6, 8. Odd means that they point in opposite directions. And even means they point in the same direction. So I'm going to go back up to the top for a minute and show you an example, okay? So I'm going to come back to this. These point in the same direction. So this one would be an even degree. So it'll be a 2, 4, 6, 8. These points in opposite directions. So this would be an odd degree. It's either 1, 3, 6, 5, 579, something like that. Okay. This one is actually degree 4, where this one is degree 3. Okay. So this is a cubic function. This is a quartic function. All right. So I just wanted to show you the difference, opposite and same. If it's odd, which means it points in the opposite direction, and it is negative, a leading coefficient, if your leading coefficient is negative, it's going to look like this. If your leading coefficient is positive, it's going to look like this. Remember, we don't care what happens in between. We just care about the two end arrows, okay? So that's why I'm just drawing linears. We just care about the two end arrows. If it's in the same direction and the leading coefficient is negative, it's going to look like a frowny face. If it's positive, it's going to be that U shape. So that's kind of your cheat sheet on this little next part. Okay. So we're going to do a bunch of these just with the equations, okay? Very good. All right, so we're going to start with this equation. The first thing that we're going to do is these two parts down here, and then I'm going to put the end behavior in this big gap because it's easier to put there. So the first thing that we're going to do is find the degree. What's your highest power? 3. What is the number that leads that? 1. All right, so down to our chart, if we look at our chart, this is an odd degree. So that means it's going to point in opposite directions. This is a positive 1. So that means it's going to look like this. Opposite directions and positive. That means it's going up. Once you have that sketch, remember, we don't care what happens in the middle. We just care about the end. We're going to do our left and our right. Look at your sketch. The left is pointing down. So that's at negative infinity. And the right is pointing up at positive infinity. So you do not have to have the graph. Can you graph it? Sure. Use your calculator and graph it if you don't like this. This is just kind of a cheater way to do it. All right. So if we look at the next one, what's your highest degree you have? 3. That means that it's odd, so it points in opposite directions. Your leading coefficient is -2. And all we care about is that it's negative. So opposite and negative is going to look like this. Opposite and negative looks like this. So again, we do the left and the right. Those will never change. You will always write those to begin with. On the left, this graph points up. So it's positive infinity. On the right, it points down. So it's negative infinity. I'm going to drop to the box below it. What's your degree? Highest power is 5. That's odd, so it means opposite. Your leading coefficient is 1, and all we care about is the fact that it's positive. So opposite directions and positive looks like this. We always start with left and right, so x to negative infinity and x to infinity. There's your left and right. On the left, it's pointing down, so negative infinity. And on the right, it's pointing up, so positive infinity. Look at the top right-hand box. What's your degree? So that's even. Your leading coefficient. So that means it's negative. Even means they point in the same direction. Negative means it's a sad face. So it's going to look like this. We always start with the left and then the right. And then both f of x's should be what? Say it again. Negative infinity. They're both pointing down, so they should be the same. On your next one, your highest power is 4, which is even. It points in the same direction. Your leading coefficient is -1. It is negative, so that means same direction is down. Again, if you're not getting that, just put them in y equals or put them in Desmos and graph it and you can see it. Okay, it's not a huge deal. So on the left and on the right, they're both pointing down. So just like the last one. Again, doesn't matter what happens between. Then the last one on this page, your highest power is 4, which is an even. That means they point in the same direction. Your leading coefficient is a +1. That means it's a U shape. We always start with the left and then the right. They're both pointing up, so they're both going to be positive infinity. We're going to do this a couple more times. All right, same thing. I'm not going to do all of these, so don't, I mean, you can go ahead of me if you want to, but I'm just letting you know. We're going to do the first one. It's 2x to the 4th. Your degree is 4, which is an even, which means it points in the same direction. Your leading coefficient is 2. All we care about is that it's positive. So it looks like a smiley face or a U. We always start with the left and then the right. Those will never change. And then since they both point up, your f of x's should both be positive infinity. The next one, our highest power is 5, which is a negative. I mean, not a negative, it's an odd. That means it points in opposite directions. Your leading coefficient is -1. So that means it points down. Again, if you're not getting that, make sure you know how to find the degree and the leading coefficient. But if you're not sure which way it points, just go ahead and graph it. We start with the left and then the right. That never changes. If we look at our graph, the left side points up, so it'll be positive. The right side points down. All right. I'm going to skip this one and go to the other one here. We have a -x. The degree is 1, which is an odd, opposite direction. Your leading coefficient is -1, so it's negative. It's going to look just like this one. Okay, these are exactly the same. I just wanted to do one that didn't have an actual power. So on the left and then on the right. On the left, it points to positive infinity. On the right, it points to negative infinity. All right. I'm going to stop with those and then move down. This is just summarizing the left and right end behavior of all even degree polynomials go in the same direction. So even degrees go in the same direction. This is the chart in sentences. That's all it is, okay? Odd degrees go in opposite directions. It says the right end behavior of positives. So a positive linear would look like this. A positive even would look like this. It's only talking about the right. So it would go to infinity. The right end behavior of all negative. So if it were odd, it would look like this. If it were even, it would look like this. It's only talking about the right side, would go to negative infinity. And again, you already know that from the chart. Any questions so far, Logan? We're just going to keep doing the same thing. This chart is the same flow chart that I just gave you, so we're not doing that. You can refer back to the chart that I drew. And we're just going to go over this one more time. Identify the end behavior of 8x cubed minus 2x. So we need the degree, and we need the leading coefficient to begin with, so that we can sketch it and then do our end behavior. So what's your degree? 3. What's your leading coefficient? So degree means odd or opposite. Your 8 is positive. So opposite and positive looks like this. You will have to pick out your degree and your leading coefficient. So you definitely need to know how to do that. But again, if you don't know how to do this graph part, just put it in your calculator or in Desmos, okay? So that you can see it. So we start with the left and then we move to the right. In this function, the left side points to negative infinity and the right side points to positive infinity. Now, what I will tell you is if you get multiple choice, they're actually switched. And what I mean by that is they interchange these. Okay, so don't freak out if you see it that way. We're looking for left and right, and then we write it backwards. All right, so I'm gonna show you exactly what a multiple choice would look like. We're gonna identify the end behavior. We're gonna find the highest power. What's your highest power? 6. So our degree is 6. That means it points in the same direction. Our leading coefficient is -6. A negative means it points down. So it looks like this. So here's the difference. When I start with my left and my right, the way that they typically give it to you is with your f of x first. So watch how hard this is. I write f of x on the top. On the left, it points to negative infinity. On the right, it points to negative infinity. That's the difference. So don't freak out if you see it like that. And then the next parts are pretty easy. Okay, so we're almost done. All right. So identify whether the function graph has an odd or even degree and a positive or negative leading coefficient and justify your answer. So you will have to do this. So remember, odd means it's pointing in opposite directions. Even means it's the same. Negative is either going to look like this or this. Positive is always increasing. So don't forget that. All right, so if we look at the first one, It's opposite directions. One is down and one is up. So that means it's going to be odd. Justifying your answer is because it's opposite. And then does this one increase or decrease? If I draw a straight line, it is positive because it's an increase. That's all you got to do. That's all they're asking. So the next one, is it odd or even? Why is it even? Same direction. And you can just put same. It's not a big deal. You're not going to be doing that on your homework. And then, is it positive or negative? How do you know it's negative? That's it. Real simple. All right. So then on the next two, it's just asking you to make a function. It does not matter what function you make. But the only thing you need to know is what it does. Okay. So give an equation of a polynomial with the end behavior on the left goes to negative infinity. So if we go back to that chart, on the left, it's negative infinity. On the right, it's negative infinity. So what do we know? Is it odd or even? So it's an even degree. Is it positive or negative? And a negative leading coefficient. It does not matter what function you give me. It does not matter. Okay, so here's a function. I need a negative leading coefficient. I'm gonna write -4. It doesn't matter what number. It could just be negative, okay, like a -1. Then you write your x, and then I just have to have an even degree, 4. You could have given me -x². You could have given me -6x⁸. It doesn't matter. You see what I'm saying? So you can give me anything as long as it was a negative leading coefficient and it was an even power. So on the next one, it says the left goes to negative infinity and the right goes to infinity. Left goes to negative, right goes to positive. So this one is what? Opposite. So it's odd and it's increasing. So it's going to be a positive leading coefficient. So you can give me any number at all as long as it's positive. So I chose 6, it's just a random number. And then any odd degree. You can do 1, you could do 3, you could do 5, you could do 7, you could do 9. So again, I could have just done x⁻⁻. I could have done 9x⁻⁷. It doesn't matter, okay? Just as long as you have a positive leading coefficient and an odd degree. All right, 2 more. 2 more and we're done. Sketch the graph of a polynomial function with a positive leading coefficient and an even degree. What does even degree tell you? Same direction, right? And positive means it's pointing up. Sketch that. Yeah, that's it. Don't make it complicated. It could have been something like this, as long as they were both pointing up. Okay, we don't care what happens in the middle. We only care about the ends. And then the last one, a negative leading coefficient and an odd degree. Odd means opposite, and negative means it's decreasing. So starting high, doesn't matter what happens in the end, as long as the other side is pointing down. Okay, it could have been simple as a linear. It could just be one little squiggle there, it doesn't matter. Got it? Everybody okay? All right, so that's all of your notes. I'm gonna stop sharing, stop recording.